Hey class, Mr. Bean here. I'm in with my A1 Honors Physics class, and we're making a video presentation on the theory for Lab 11, free fall egg drop. Okay. All right. So this is going to be a continuation of the last lab we did, and let's get right down to it. So in this case, just a quick review. We have our object here, and it's going to be starting at rest. So this is going to be 0, right? And it's going to be falling in this direction. Now, since it's falling in this direction, we'll do our frame of reference. So we'll call this FR, which is our frame of reference. In this case, we're going to make going down to be positive. Because we established going down as positive, G will have a value of positive 9.8 meters per second squared. Now, next time we meet, we'll be tossing it upward where G will have a negative value. Okay, so right now it's positive 9.8. Okay, this is okay, just a little background. All right. Anyway, so we go over here, and here's our center square. So here's our bridge here. Okay, and we'll go right here. It's a center square, and we'll go ahead and use a brown railing here. Here's brown, and we'll kind of put it right here. Okay, so this is the brown railing. Okay, now this part is going to be critical because you have a parachute now, and what happens is that, okay, so we're going to have a Dixie cup here. Let's say here's the Dixie cup. Okay, and let's say the egg is here, and then we have like some string and some string here, and here's our parachute device. Now, the parachute does not have to be very big. A lot of people from last class, they use the whole entire bag over here. You don't really need a huge bag, so because you can do this several times to make sure the egg does survive. Okay, now this is the important part. When taking your video, if this is not dropped at the level of this, you have to redo it again. So we had multiple people who dropped the egg from down. I mean, they had the parachute here, but they had the egg dropping from down here. So that's a no-go. So when you do this, the egg container must be dropped here. As it falls, the parachute will catch air and slow it down. Okay. Or you could, cut the parachute in half, and you can try several techniques to get this down. All right. So here we have our this even here any Fantastic Four fans or Marvel fans? Okay, this is Dr. Reed Richards. Okay, what's his power? He can stretch. Okay, so this is Dr. Reed Richards. Okay, he can he has elastic ability. He can stretch, right? Okay. All right. So, anyways, we'll put down Fantastic Four. All right. So we're right here, and same thing over here. We'll have a person, and this person will be the video guy. Okay, the video person. Okay, and he was going to videotape the entire event. Okay, this will be video. And what information do we get from the video person? Time, yes. Okay, in fact, we'll call it delta t, the time interval. Okay, we get that from the video person here. Okay, all right. So when we drop it here, when we drop it from free fall, it's going to be at rest. So if we drop it at rest, what's the initial velocity in the y direction? 0. Excellent. Okay, and we also know that g is going to be 9.8, right? 9.8 meters per second squared in this direction. Okay. All right. Now, what's this distance here? Do you remember from what was it? Yeah. Delta y is 5.2 meters. So we're going to have to establish that's why it's important that we drop this at imaginary level here of 5.2 meters. Okay. All right. So here's all of our preliminary information here. Now, when we do this here, now the video person here, I'm going to provide you with 2 times. Okay, I'm going to give you a TO time, right? Okay, and the TO time will be there'll be like like a decimal point here, and this is going to be we'll call it frame divided by 30, right? Because it's 30 frames per second. So I'll give you what the whole number value is for the second, and I'll tell you what frame it is. And you have to divide it by 30 to get the decimal. Is this what we did last class? Right. Okay. Okay. And then the final time, just like before, I'll give you the whole number value. You have to take the frame number that I give you and divide by 30. Okay, and then that will get you the initial time and the final time, and then we can do delta t to get the duration, right? Delta t. Okay. All right. So this will probably be our first calculation that we need to do is this situation here. Okay. So whoever takes the video, make sure as soon as it's done, send it to me as an email attachment because it may take several minutes to get to me. Now, you might check your bars. If you have 3 bars or 4, if you have 3 or 4 bars, make sure you do it in centimeter square. Okay. Or you may have to step outside. Okay. All right. So any questions about this part here? Any questions? Yeah, what's new is I did this all for you yesterday, but now I'll just give you the frame number. Okay. All right. So as it falls here, it's going to catch air, right? It's going to slow down and so on and so forth. Hopefully it slows down. Okay. All right. So second calculation that we'll need to do is figure out, okay, second calculation is what's the acceleration? Okay. Uh, what's A? Okay. What is acceleration? Okay. Any ideas what equation I should use or how should I approach this? Is it like equation number 5 from the sheet? No time or do we have time? Yeah, we have time. Yeah, yeah. So equation number 4, except we'll use it for vertical. Okay. So here we have delta y here, right? Is equal to v o y t, right? Plus 1/2 a t squared. Okay. All right. So here's our formula here, right? And what's v o? What's this value here? 0. Yeah, because it starts from rest, so that's going to be 0, right? What's delta y? Yeah. Yeah, you guys get man. Yeah, 5.2 meters, right? 1/2 is 1/2, right? Okay. Here's a, and this is going to be delta t, our duration, squared, right? So from here, can we solve for a? Yeah, using our advanced algebra skills, I can multiply both sides by 2 and divide by delta t squared. Okay. All right. So here's a, right? So multiply both sides by 2. This will become 10.4, right? Divided by delta t squared. So this will get us our acceleration. Okay. And we can actually compare this to our lab number 10 because this should be dramatically less, almost half. Okay. Okay. All right. That's equation number 2 or calculation number 2. Okay. All right. Okay. So here's equation calculation number 1, calculation number 2. All right. Any questions so far? Any comments? Okay. All right. So that's why it's important to get this delta t here, right? Okay. All right. So the third calculation, okay, third calculation is going to be we have here is velocity. We'll say velocity, right? Velocity at impact. Velocity at impact. Okay. All right. How many ways can we calculate this? Is there 2 methods? One with time and one without time? Okay, well, if we forgot, so one method is to use velocity is equal to VOY, right? Plus A delta T. Okay, so what's this value here again? 0. Okay, and do we have acceleration? And do we have our delta T? Yeah, so we can find out what it is here. So we can use this one here, and we also want to use this one too as well. V squared is equal to VOY squared plus, was it 2 A delta Y? Okay, all right. So there's no time involved here, right? And what's this value here? Anybody? 0. Yes, this is 0. All right. So from here, we should be able to solve for v squared. Okay, or solve for v. All right. I'm going to add one more page here. And okay. All right. So we'll wrap it up right here. Objective. Okay. Objective. Okay. All right. Has to be measurable or has to be discernible. Objective is to drop egg. Right. Drop egg using, um, okay, using parachute system. We'll say is it CH? Is it U T, one T or okay, okay, yeah. Using parachute system, uh, drop egg using parachute system. So when it lands, when it lands, uh, there are no cracks. No cracks. Okay, no cracks. Okay, now if you have a crack, you have to do it again. You have to improve upon your parachute system. All right, that will kind of wrap it up. So, does anybody here want me to post this on Google Classroom? This sheet right here? Okay, and the video too as well. All right, that is it. We'll hit stop share and then away we go.